Assalamualaikum and good day everyone. Today I would like to give you an example of body application in our daily life. So this is the first question, which is a cylindrical steel rod with R equals to 0.01 is formed and heated and allowed to cool in still air. Find time to cool rod from 200 degrees Celsius to 100 degrees Celsius. The temperature distribution along the rod is given by the differential equation. So this is the equation that we will derive from the first equation, which is negative 20 by r square in the bracket of t minus 25. This is a classic example of Newton's law of cooling. It tells us how the temperature of an object changes over time as it cools down towards the ambient temperature. The rate of cooling is proportional to the surface area, which is represented by r square, and also proportional to the temperature difference between the object and the surroundings. Our task is to solve this equation and to find an expression for T, the temperature as a function of time. Now we begin to solving the equation. First, we will substitute the value of R, which is equals to 0.01. Then it will give us negative 6.2833 times 10 to the power of negative 3 in the bracket of T minus 25. This is a separable differential equation, so we will separate the variables and integrate both sides. Then after we integration, we will get ln t minus 25 equals to negative 6.2832 times 10 to the power of negative 3 times t plus c. And we will exponenting both sides, and the generic solution will becomes t equals to 35 plus ae exponential of negative 6.2832 times 10 to the power of 3 times t. To find the value of the constant a, we will use the initial condition given, which is T0 equals to 200 degrees Celsius. Substitute to our equation, and the value of a we will get 175. Then we will substitute to our general equation, which is we will T equals to 35 plus 175 exponential of negative 6.2832 times 10 to the power of negative 3 times t. So, to find the time taken for steam rod to cool down to 100 degrees Celsius, we will substitute it to our general equation, which we will get the value of t, which we will get 134.3 minutes. Thank you.
Assalamualaikum and hi. So we are from group Sampai Esok. We are going to present our topics about second order derivative. So let's move on to our main objective. So in modern smart grids, the dynamic of a simplified local voltage response in a part of the grid can be modeled by a second order linear non-homogeneous ODE. So given the equation is LD square I over dt square plus RDI over dt plus 1I over C equals to ET. So we want to find the general solution given that L equals to 1H, R equals to 0.5F, ET equals to 5 sin 3T. So the parameters are given below. Firstly, we substitute all the values and then find out the IH and IP, where we obtain a complex number form for IH and trigo form for IP. Next, we substitute all the IP and its derivatives back into the equation, then rearrange properly. So the next step, we are going to compare the left and the right hand side. So we're going to compare negative 7a plus 6b to 0 to find the a, and we're going to compare the negative 6a minus 7b to 5 to find the b. After we get the a, which is negative 6 over 17, and b, which is negative 7 over 17, we're going to substitute a and b into our IP. So the answer for IP, we're going to get negative 7 over 17 cos 3t plus negative 7 over 17 sin 3t. Since we had developed the general equation, let's find the current response at 3 seconds. First, we notice that there is no current at t equal to 0, thus I and I prime is equal to 0. As we put the value, we obtain the value of C. Find D, we differentiate the equation and then put 0 into I prime and t. So as we obtain those values back into the general equation, then we got 0.146 ampere as the answer. So by solving the equation, we can predict the current behave, design safer and more stable power system, and analyze the dynamic system using math. We can also adapt with the new tech where we know to relate, understand, then solving problems and applying math in real problems.